Hey everyone, today we're going to be learning about how to read the periodic table. So the periodic table is just a tool that chemists use to organize all the elements that we know. So there are a few ways in which the periodic table is organized. So one of those, if you notice going left to right at this number at the top of each square, so 19, 20, 21, 22, that's what we call the atomic number. And we talked earlier about how that just tells me my number of protons. So the periodic table is organized from left to right by number of protons. So if we just take this whole row that we talked about going left to right, all the rows on the periodic table, we just call these periods. And the other term that we're going to start off here with is if we look from top to bottom, like this. So a vertical column is just what we call a group or a family. And the reason that elements are grouped into these families vertically is all the elements within a family are going to have very similar characteristics. So the family that I just outlined here, this is what we call the halogens. And all the halogens are going to have very similar characteristics in that they'll react similarly because they all have the same number of valence electrons. So if we're counting left to right, the periodic table has 18 groups. So another name that we could call this family that I outlined here, this is group 17. And in addition to the 18 groups, we have 7 periods. So 1, 2, 3, 4, 5, 6, 7, all the way down. And these two that you see here that are kind of removed, these actually belong right here. So these would be part of 6 and 7, but in order to save space, we kind of cut this section out and put it down at the bottom. So before we get into a little more detail here, I want to go through a quick definition. So valence electron is the term I mentioned a little bit earlier. So just to give you a little visual of what that means, is every element has a set number of electrons. So we learned earlier that sodium has 11 electrons, and of those electrons, only one of them is, quote, valence electron. Valence electron just means it's the electron that's on the outermost layer. So if you look at sodium right here, we have 3 layers, and if you look at the outermost layer right around here, there's only 1 electron right there. So we'd say sodium has 1 valence electron. If you look at nitrogen, nitrogen has 2 energy levels, and on the inside level we have 2, and on the outermost level we have 5. So nitrogen, of its 7 valence electrons, we have 7 total electrons, 5 are valent. All right, so we said sodium has 1 valence electron and nitrogen has 5. So just to show you a little trend here, and there's an easy way that just looking at the periodic table we can tell how many valence electrons any element is going to have. So every element in group 1, sodium included, is going to have 1 valence electron. Then everything in group 2, so beryllium, magnesium, calcium, everything in this blue group right here will have 2 valence electrons. If we skip over this yellow section right here and move over to the boron family, boron and everything below it is going to have 3 valence electrons. Carbon's family will have 4. Nitrogen, as we said earlier, will have 5, and everything below it will also have 5 since they're in the same family. Oxygen's family will have 6. Halogen family, which contains fluorine and everything below it, will have 7. And the noble gas family, which is this column on the far right, will have 8. So helium, which I covered up, is an exception to that. So we'll talk about helium later, but neon, argon, everything right here will have 8 valence electrons, which is as many valence electrons as it's possible to have. So because of that, this whole noble gas family will not react with anything. So now just to run through the names of these families real quickly. So this left side family, the alkali metals, everything here with 1 valence electrons. Hydrogen is excluded from that since hydrogen kind of has unique characteristics. Everything that's over here on the far left is going to be an alkali metal, and they're all going to react very strongly with water. So it's because of that 1 valence electrons that they will react similarly. Next family over with 2 valence electrons, the alkaline earth metals. The transition metals, which is the big section in the middle, that includes copper, nickel, zinc. These metals tend to be really good conductors. The halogen family, as we discussed earlier, is going to be group 17, and the noble gases are going to be that family on the far right.